Welcome back to the classroom. I'm Mr. Wong. Today we'll be covering the 2019 Catholic Physics paper. This is to cover Module 5. Inquiry question 2, which is on circular motion. This is question 32. It's worth 8 marks. So in this question, it says a car rounds a bend on a road that follows the arc of a circle with a radius of 25.6 meters. The car has a mass of 885 kilograms. The force of the kinetic friction on the tires is 942 newtons. Okay. Question 8 says, what's the maximum speed should the car be moving to stay on the road while taking the bend? So in this case, if we're talking about a flat horizontal curve, our centripetal force is equated or caused by our friction force. Okay, so 9,420. Okay, and we can use mv squared over r. If we rearrange the equation, it should look something along the lines of v equals 2. Let's see what we have. We have 9,420 times our radius, which is 25.6 meters, divided by the mass, which is 885 kg. So if I plug that into my calculator, let's see what we get. I get about 16.5 meters per second. First question done. Question B, it says using physics principles, answer your answer to question A quantitatively. Okay, so again, using explanations and calculations, explain why the motorists are advised to drive at a speed lower during wet weather. Okay, so in wet weather, we know that friction on the road is decreased. So friction on road decreases. Hence, the centripetal force decreases. Hence, and so as a consequence, thus the circular motion or the radius of the circular motion will increase, will go up if v is still 16.5 meters per second. Okay, so in terms of what physics principles we could use, we can talk about, and so whose principle can we explain? So we can actually use Newton's second law of motion. Newton's second law, F, we can use F centripetal force and ma as F decreases, therefore we have a decrease in our centripetal acceleration, or the capacity in which it can change its centripetal acceleration. So that's the case. Okay, so if we look at our formula, F equals mv squared over r, if this is constant, but this decreases, okay, then radius will have to increase due to that. And so part of the question is, why do we need to drive slower? That's because we have a lower centripetal force. Hence, drive slower. Due to smaller centripetal force on road, or if you want to be really clear, you say friction force on road there. Okay, so there's that, and that's good. We move on to the last question.
Okay, so looking at question C, as you can see, it's looking at when the roads are built, they're banked, it forms an angle to the horizontal as shown in the diagram below. If the bend in part A were banked at 8 degrees to the horizontal, show qualitatively how this increased the maximum speed that allows the car to remain on the road. Okay, so the idea here, we have the centripetal force. We know the centripetal force is contributed by two things. Okay, one is the normal force, which we can find as a component of the gravitational force. The component of the normal force that contributes to the centripetal force is its horizontal component. Okay, so like we see here. And the second one that we will have is the horizontal component of our frictional force. So frictional force is caused in this direction on the banked road. If we draw it out with simple trig, or simple triangle, right angle triangle diagram, we can tell that it is the horizontal component of that friction force that will create the additional centripetal component. So we have our flat road, which only has centripetal force causing the rotation, while as on a banked road, we have the normal force component and also the friction force component acting on it. Okay, so that's what we're dealing with. So we can firstly work out what the normal force is because it's a component of the gravitational force. Okay, so let's just get into that. So we have our normal force, and it's going to be the component of Fg, which is mg cos theta, okay, because it's an adjacent side and the hypotenuse on the right angle triangle. So mg cos theta and then we also have the component of the friction force, because the friction force also has a y component, so it's also contributing to our gravitational force pulling down. So our normal force needs to overcome firstly the component of the gravitational force and also the component of the friction force. So we do need both of those. That should be friction sine theta. I did make a little error when I was writing this through overall. I am doing a voiceover here, so I do apologize if my words don't quite sink in with whatever I am writing at this point in time. So the normal force component, the horizontal x part, is F normal sine theta. So that's what we're dealing with here. So in this bit here, I'm just trying to work out what the exact numbers are. So I'm going to skip over that. Okay, so we have 885, 9.8, as you see the numbers there, cos 80 or cos 8 plus friction force. Now I do change that into sine 8, not cos 8 after the friction force. Okay, so just fixing up the numbers here. Got 9,000, 899.61 newtons. So substitute that into our equation, and that should give us the value for the normal force component, or the normal force x component. Okay. So 1377.76 newtons, so that is the normal force component, or the normal force horizontal component that we're looking at here. And then we have our centripetal force, which is made from normal force horizontal plus friction force horizontal. And so we have the value there, and also we can work out the horizontal component of the friction force using cos 8, okay? And that leaves us with an answer going through the calculations. And we get 107.06.08 newtons. So that's our centripetal force. If you actually have a look at our original friction force, we're already much higher in terms of the friction force of a horizontal road in comparison to a banked road. So you can sort of tell from that already that a banked road will allow you to travel at a much higher velocity because if you have a stronger or greater net force pulling you in, you have the ability to drive a lot faster and maintain the same radius. Okay, so substitute those values in. Always try and change the color to make it look pretty, but you don't really have to, really. So now I'm substituting the value for centripetal force, and I'm also going to place the value for radius, divide that by the mass. All said and done, this step is a lot more straightforward than the steps that we did just then. And all you have to do is substitute into your calculator, and I get approximately 17.6 meters per second squared, and that is my velocity, you could say, if we're going around a bend. Okay, so what we can say for sure is on a flat road, we travel at about 16.5 meters per second. So in comparison to what we have on the bank road, the bank road option allows us to travel a lot faster because there is a greater net force, which is also our centripetal force. Okay, and that's how you essentially do this question. If you found it useful to have someone explain to you these exam questions, please give this video a like, subscribe if you haven't done so already, and I'll see you next time. Thank you very much.